Hi, here we are doing our little video lectures. So I wanted to start off by just bringing you back a minute to 9.1. So 9.1, we did a couple of things. We basically obtained a point estimate, which meant in this case we were dealing with a proportion. So I'll put that right here. So it was basically thinking of like a population and saying, oh, okay, I think that the number of purple Skittles in a bag of Skittles, for all the Skittles in the world, so it would be a proportion, I think they account for, let's say, 40% of the bag, which means if the bag has 10 Skittles in it, 4 of them are purple, so 4 out of 10. So proportion, remember, is, well, like if we're doing a sample, the p hat is the x over n. So if I had 4 purple Skittles over 10 in the bag, then my proportion is 0.4. So that's what we were focusing on for 9.1. So the reason I'm bringing us back to that is just so that you have a little bit of, I don't know, basically that you can think about what we're talking about when it comes to the point estimate. So let's say I thought that there were 0.4 or 40% purple Skittles in a bag. And what I would do then is I would say, okay, my point estimate is 0.4, right? Then the second thing we would do is we would construct a confidence interval. So for the confidence interval, we would say, well, I'm a certain percent confident, let's say I'm 95% confident that the number of Skittles or the proportion of purple Skittles in a bag is 0.4, which is our point estimate, but we would give an interval. I'm 95% confident that it would fall in this range of, let's say, 0.3 to 0.5, right? So there were 3 things we needed for a confidence interval. We needed our level of confidence, which in this case is 95%, and then we needed the lower limit and the upper limit. And our point estimate would be right in the center of that. If I wanted to find the error, the margin of error, it would be the difference from the 0.5 minus the 0.4. So how far is it from here to here? It's 0.1, or 0.4 minus 0.3. So either way, because the 0.4 is in the center, then the distance from 0.4 to 0.5 will be the same as 0.3 to 0.4. And whatever that distance is our margin of error. So we constructed confidence intervals. And in order to do that, what we did was we used StatCrunch. And that was stats, proportion stats, 1 sample, typically with summary. I'm not going to write that because most of you have already done 9.1, but I'm just trying to get your head back into the game for a second because it's been a while, right? The other thing that we had to do was give the qualifiers. So in order for this to happen, the qualifiers in this case were that this had to be satisfied, n times p, 1 minus p, these are p hats, right, because it's for the sample, and that had to be greater than or equal to 10. Everyone loved doing that. And then the second one was that the sample size had to be less than or equal to 5% of the population size. So in some of the questions, they made us qualify that. So I'm just bringing that back as a little bit of a review. And then the other thing that they had us do is sometimes they would give us the confidence interval and they would tell us the width of that interval, and then we would have to find the sample size. And we would also use StatCrunch for that. And in order to do that, we would do stats, proportion stats, 1 sample, instead of with summary, or I'm sorry, we would go all the way down to the bottom to the one that said width. I don't know if you remember that or not. But anyways, so what's happening in 9.2 is similar. We're going to be basically doing the same 4 things, But what's different is that instead of our point estimate being a proportion, it's going to be a mean. So we're going to be looking at some X bars in there. If it's the population mean, then it would be mu. Okay, so the whole idea for this is to basically look at samples, find these estimates or whatever, so that then we can make some big statement about what the population must be. The confidence interval is basically saying, hey, if I do, let's say 100 of these samples, I take 100 samples, then this point estimate, 0.4, is going to be in the confidence interval of 95 out of 100 of those confidence intervals, and that's what gives us the 95%. So I know this feels a little bit broken. I think I'm not quite explaining it very well, but the whole point is I'm trying to keep it as simple as I can so that you can just focus on the differences between 9.1 and 9.2. And the main difference is 9.1 is dealing with proportions versus 9.2, which is dealing with a mean. So instead of me saying, well, there are 40% purple Skittles in a bag, for the mean, I would be talking about, well, what are the average number of purples in the bag? And so assuming I looked at, a whole bunch of samples, I might say, well, whatever, the average number of Skittles in the bag is 6, or, whatever, could be 4, just to be similar to our 9.1 proportion. Anyways, so what we have to do in this section is we still have to find a point estimate, but in this case, we're referring to a mean. We're still going to be doing a confidence interval, but instead of using our proportion stats on StatCrunch, we're going to use t-stats. So we're going to go stat, t-stats. So the t is referencing the mean, whereas in 9.1 we were doing proportion stats. And then everything else from there is pretty much the same. It would be one sample with summary, unless you have a list of data, and then it would be with data. I've created some really cool homework help sheets that I'm going to email to you, and I'll explain those to you in the email. But it goes through step by step for each question to kind of answer some of the typical, issues that people have. So will you be building a confidence interval? Yes, you will. You'll do it through StatCrunch with t-stats, just like you did over here, stat, and then proportion stats, okay? What else will you be doing? You will be potentially finding the sample size as well, okay? And then in addition to that, you'll also be having to do this qualifier. So the qualifier for 9.2 would be it either came from a normal population, or, and this should sound familiar, or the sample is big enough, and they're going to basically say 30 should suffice in most cases, okay? And then this part is the same. The sample size has to be less than or equal to 5% of the population size, okay? The fourth thing is they may ask you to find the sample size. And if you do, then that's where you go down to that width on StatCrunch. Instead of doing the confidence interval, you go down to the bottom part of the menu that says the width, and then you plug in the stuff that you need to plug in. Okay, so the main added thing to 9.2 that you did not see in 9.1 is that the textbook is going, or the homework questions in some cases are going to assume that you're doing the confidence interval using the formula. And the formula is on your notes. I'm going to write it up here just for a second. Okay, I don't want you to get too freaked out about it, but I want to write it up here so that you understand where some of these questions are coming from. So if I wanted to do the confidence interval using the formula, it would look like this. I would have the mean of the sample plus or minus, because the plus would be the upper limit, the minus would be the lower limit of my confidence interval. This T alpha over 2, and then times S over the square root of n. Now, luckily, you don't really have to do this formula by hand. There is one question that's a little bit interesting where you have to plug those things in, but I go through step by step on that one. But I'm pointing it out because if you were to use the formula, one of the things you would have to practice is this issue of finding the t alpha over 2. So towards the beginning of the 9.2 homework, there are going to be a couple questions that are making you find that t alpha over 2. And what you'll use is, these are called t values. You're going to use your calculator t as opposed to your calculator normal. So calculator, and I put this in the notes for doing each homework problem. So I'm just trying to throw this out there so that it doesn't come completely, you know, like from left field somewhere. Okay, but I'm not going to go into it in the lecture because I think the notes are very, very helpful. All right, so 9.1 is proportions, the p hat, right? We're finding a point estimate so that we can say, oh, this is what we think that the proportion is for the population. How confident am I? I'm going to make a confidence interval, right, using my StatCrunch. I have to make sure these are satisfied before I can do it. And then in the questions towards the end of the homework, they ask us to find the sample size. 9.2, same type of thing. We're just talking about means as opposed to proportions, right? Mean is like an average. So I'm still going to use StatCrunch to do my confidence interval. So maybe I should have put 2 here for that. My point estimate is a mean, right? So we're going to use mu as my point estimate. I still have to have these qualifiers, and then towards the end they asked me to find the sample size, and I'll use StatCrunch to do that. Okay, so well, let me close it off there, and then I'll open it back up with 9.3 as a separate video. And then well, before I do that, let me just talk about something real quick, because this will come up in the homework. So a couple of key things. One is that obviously, and I've talked about this before, you will need to be able to interpret a confidence interval. 3 things needed for the interpretation of a confidence interval: the level of confidence, the lower limit, and the upper limit. We've talked about that before, and I just barely mentioned it when I was talking about 9.1. The second thing is this issue of sort of understanding what happens as the sample size, so as n increases, then what happens to, let's see, what happens to the margin of error? Okay, so this is the first question. So n is your sample size. So I want you to think about it like this. If I really wanted to know the average number of Skittles, purple Skittles in a bag of Skittles, and I only looked at 2 bags, and let's say one bag had 6 and one had 1, and I said, well, you know, the average is what, around 3.5, something like that. But I've got a lot of error there, right? Because I only looked at 2 bags. But let's say I looked at 100 bags of Skittles. Hopefully, intuitively, you would start to say, hey, I think I'm going to be more accurate. So my margin of error, the amount that I could be wrong on left and right, is going to be smaller. So that as n increases, then the margin of error decreases. Okay? So that's one thing that they're going to ask you in a multitude of ways. But I want you to kind of own that in your head so that when you read the question, you can really start thinking about it. The more bags of Skittles I look at, then the more correct my answer will be. So I won't need this big, huge margin of error in my confidence interval. It can be very small, right? I'll be very accurate, okay? So that's one. The second one has to do with my level of confidence. So as my level of confidence increases, so I'm more confident, then what happens to the margin of error? So this one, I think is a little, I think our brain twists it around. And let me just give you an example of, let's say, a target, okay? So let's say that I wanted to know, you know, let's say I wanted to drop my pen on this board, and here's my target. That's a pretty big target. So how confident am I that I'll hit it? Well, I'm pretty confident. That's a huge target, okay? Think of my point estimate as my middle. So if this is my point estimate, and my margin of error would be how far I am to either side. Okay, so this is my margin of error. So if my margin of error is huge, I've got all this room in my target, then my confidence is big. I have a lot of confidence that I can hit this target because I have a lot of room for error. So as your confidence increases, it's because the margin of error also increases. And the weird thing is that I think typically we would actually say this the other way around. Oh, as my margin of error increases, then my level of confidence increases. But for whatever reason, they often word it backwards. They talk about the level of confidence increasing first, and I think that that's what kind of throws people. All right, in contrast, if I had to drop my pen and I only had this little tiny target, like right here, let's say, I had to hit that. So my margin of error is just this little distance, right? I've only got from the center to here and then from the center to there. So those little lines are my margin of error. How confident am I that if I drop my pen, I will hit that? Oops, I missed it. Oops, I missed it, right? I still missed it. I thought I was going to hit it that time. Anyways, so what does that say? My confidence in hitting this is smaller because my margin of error is smaller. So these are two important concepts that they're going to talk about in several different ways. And I think if you can first just understand it, then you'll feel a lot less crazy when you're doing it. Okay, so I will see you on 9.3.